Braking down on the highway is stressful enough without having to worry about how your car is getting home. For decades, the math was simple. If a car broke down in the middle of traffic, you called a tow, and a standard wheel lift truck showed up. The operator hooked up 2 wheels, dragged the other 2 behind, and it worked perfectly fine. That instinct to just accept the first truck that arrives is still how most of us operate today. But automotive engineering has vastly outpaced towing infrastructure. The complex architecture underneath modern cars has evolved rapidly, yet many roadside dispatch fleets are still rolling out the exact same legacy hardware. A basic 2-wheel drive commuter car handles a standard wheel lift without an issue. But if you drive an all-wheel drive SUV, an electric vehicle, or a heavily modified car, letting a traditional truck tow you creates a hidden mechanical trap. Imagine shuddering to a halt on the shoulder. In that moment of panic, you just want to get off the road as fast as possible. Look at this quadrant chart comparing the effort it takes to source a tow truck against the risk of damaging your vehicle. Down here in the low-risk, low-effort zone, we have standard front-wheel drive commuters. Practically any tow truck will do. But look what happens when we chart EVs and all-wheel drive systems. They shoot straight up into the high-risk, high-effort quadrant. These drivetrains require highly specialized handling. Mismatched towing equipment leads directly to total mechanical failure. Let's look closely at the mechanical baseline of all-wheel drive systems. In these vehicles, all 4 wheels are permanently connected to a central transmission and a transfer case. They operate as a single linked system. This comparison matrix breaks down a standard wheel lift input. The truck lifts only 2 wheels, leaving the others rolling. Because of that mechanical link, the outcome is highly destructive. The rolling wheels force the central transmission to spin rapidly, while the suspended wheels remain completely locked. Here is the critical engineering constraint. You are being towed, which means the engine is off. Because the engine isn't running, there is zero fluid moving through the transmission to lubricate those gears while they are forced to rotate. Without that lubrication, you get dry, metal-on-metal friction tearing the internal components apart in a matter of miles. The trade-off is clear. You might get off the highway 20 minutes faster using whatever truck showed up first, but you will pay for a catastrophic transmission replacement as a consequence. If you drive an AWD or 4WD vehicle, keeping all 4 wheels stationary on a flatbed is a non-negotiable requirement to prevent mechanical destruction. Electric vehicles present a completely different logistical challenge. Unlike internal combustion engine cars, an EV does not feature a true mechanical neutral gear. The electric motors are directly linked to the wheels. In our matrix, a standard tow leaves driven tires rolling. The outcome is severe. As those tires roll, they manually turn the electric motor. It acts like a generator, pushing raw power straight backward into the system. This forced regenerative braking resistance creates a massive, uncontrolled electrical surge. That surge will immediately fry the high-voltage system, destroy sensitive onboard computers, and ruin an incredibly expensive battery pack. Add to that the sheer weight of EV battery packs, which place a massive strain on the physical suspension hardware of traditional wheel lift trucks. The trade-off for an EV is a total loss. Taking the immediate pickup from a standard tow truck guarantees irreparable electrical damage to the grid. You have to completely eliminate that regenerative braking resistance. That makes flatbed transport mandatory for any EV. The risks aren't purely internal either. Owners of luxury sedans, exotic sports cars, and custom lowered vehicles face distinct physical hurdles. These cars feature minimal ground clearance, extremely stiff suspensions, and fragile aerodynamic splitters. For our final matrix input, consider how traditional hardware connects. It requires thick metal forks to forcefully slide underneath the bumper to secure the tires. The outcome is inevitable. The hardware scrapes the undercarriage, frequently forcing the expensive front fascia to bear the vehicle's weight. Specialized flatbed operators use a completely different approach. They utilize hydraulic bed angling, specialty ramps, and wooden planks to create a gentle, controlled incline. By adjusting hydraulics to precision angles, the ramp sits flush with the pavement. The car glides up without the undercarriage ever making contact with the metal. The trade-off here is just wait time. Taking a few extra minutes to dispatch a specialized flatbed operator entirely preserves the asset's structural and cosmetic value. If you want to keep your bodywork intact, flatbed transport removes all risk of undercarriage strikes. When you're stranded on the shoulder of a high-speed, busy highway, the pressure is on to make a fast decision. This decision tree maps out exactly which towing method you require. It all starts with selecting your drivetrain. If you drive a standard front-wheel drive or a basic two-wheel drive commuter car, a standard wheel lift is perfectly safe. It handles these simple architectures easily, saving you time and money. But if you drive an all-wheel drive, an electric vehicle, or a car with low clearance, you follow a completely different path. You have to actively advocate for your vehicle. When you call dispatch, you must explicitly state your exact drivetrain type. If they try to send standard hardware, refuse it. You need to demand a flatbed truck. Modern vehicle architectures mechanically require flatbed transport to move safely. The goal is to get your vehicle fully off the ground, keeping it completely stationary and secure during transport. The single hour you might save by accepting the wrong tow truck will cost you weeks in the mechanic shop and thousands of dollars in preventable repairs. Wait for the flatbed.